let's talk about combinations or permutations. Now, we really use these words very loosely without really thinking about what they each mean. Let's take the following example. If you have a pizza and it has cheese, sausage, and pepperoni on it, we don't care what order the ingredients are in. They could be in any order that we like, and it really doesn't matter. It's still the same pizza. We also have a situation where we might have something like a combination to a safe. Like if a combination to a safe is 472, we do care about the order. 724, 247 won't work. It has to be exactly 472. So basically we have two different scenarios here. So if the order doesn't matter, it's called a combination. So in the example I gave you, the pizza would be a combination of ingredients. If we have a pizza again with 3 ingredients on it, it doesn't matter what order the ingredients that are in that pizza. It's the same. So that's basically called a combination. Now in a second scenario, when I talked about the combination for a safe, the order is important. Because if I have 472, it has to exactly be 472. 724 won't work, even though there's a 2, a 7, and a 4 in it. The order is important. So we don't have a combination here. We have something called a permutation. Now, it's a little bit hard to determine exactly which one you use sometime. It seems kind of easy when you think about, exactly what's a combination and a permutation. But as you kind of go into it, it gets a little bit confusing. Let's talk about a permutation. Now, we have here, an example I'm going to give you is I'm going to ask you in what order you can arrange 16 pool balls. If you play pool, you'll know that other than the cue ball, you have ball number 1 through ball number 16. So if we have to choose how many different ways they can be ordered, we basically have what's called a permutation without repetition. And let me talk about that for a second. In your mind, picture the 16 pool balls. On your left, you got ball number 1. To your right, you got ball number 16. If you take out ball 16, your 16th choice or something, or whatever, you have 15 balls that are left. So those are 15 different choices that could be arranged. If you take out the 15 ball, now you have 14 that are left. So basically, when you're taking out a specific choice, you can't put it back in. It's kind of the analogy like if you run a race. If you run a race and there's 3 people in the race, if you're running that race, you have to be first, second, or third. You can't be first and second, or first and third, or first, second, and third. So in this example, to get away from the pool balls for a second, if you have 3 people running a race, that would be a permutation of reduction, which means that every time that you pick who could come in first, that person can come in second or third. It's the same thing with this pool ball analogy that I'm showing you right now, this pool ball exercise. So again, let's go back to we have 16 pool balls. So if we have 16 pool balls, the different possibilities would be 16 times 15 times 14 all the way down to times 1. So that's going to be a really, really big number. So if you do the math on that, if you have 16 choices and then you multiply it by 15, by 14, by 13, by 12, all the way down to 1, you're going to get a huge number that you see up here on the screen. That is what we would use for a formula for a permutation without repetition if we're choosing all the choices. But we also have a scenario where if we want to only choose like 3 of them, all we need to do is multiply them together. Like for example, if we have 16 balls and we want to choose just 3 of them, in what order, or what are the possibilities that they could be ordered? So what you would do at this point is you just would take 16, because you would have 16 as your choices, and then you would multiply it by 15, then 14. So in this scenario, you get 360. When we do that, we call this what's called a factorial. A factorial has a symbol, the explanation points, which just means it's multiplied by a series. For example, 4 factorial equals 4 times 3 times 2 times 1, or 24. 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 5040. So when we're dealing with permutations, we're dealing with factorials. So going back to our exercise, when we want to select all of our billiard balls and arrange them in a distinctive different order, or in every single possible order it could be, it would be 16 factorial, all the way down to 16 times 1. And the formula would look like this. Now, in the other example I gave you, let's just say we had 3 balls out of 16. So we have 16 possible choices, right? But we only want 3 of them. So at that point, what we do is we just go from our 16 factorial and we just use the first 3 choices. So it would be 16 times 15 times 14, basically, and then, 16 times 15 times 14. And then everything from 13 down to 1 gets canceled out. So basically, again, you just get 16 times 15 times 14. I kind of went around that the long way. You can exercise the formula for permutations as the following, where you have n explanation point over n minus r explanation point, which is basically saying that we have n is a number of things that we could choose from. So in our case, it would be 16 factorial over n, which is a number of things to choose from, which would be, again, 16 minus r, which is how many we want to choose. So in this formula, we would have 16 minus 3, and it would be 16 factorial over 13 factorial, and would give us our choices, or how many different ways that we can arrange 3 choices out of 16, which would give us 3,360. Now, that's a lot to kind of go over. That's a lot to absorb. But to understand permutations, to kind of sum that up for you, remember, permutations is when order is important. So an example of that would be, as I mentioned, a lock for a lock, which might have 3 dials in it. And dial 1 would be 0 through 9, dial 2 would be 0 through 9, and dial 3 would be 0 through 9. So if I have 1, 2, and 3, the order is important. I mean, I have a 1 in there, I have a 2 in there, and I have a 3 in there, but it has to be in the order 1, 2, and 3. And we also have permutations where you have the orders being important, but when you pick a specific choice, you take it out of the pool. So, pardon the pun. So it's not available again. So that would be an example of the pool ball scenario that I gave you, or the billiard balls, where if you have 16 choices, ball 1 through 16, if you take one ball out for the choice, you don't have it there anymore. It can't be part of your second or your third choice. So that's called reduction or permutation with replacement. And when we do that, we use the factorial. So that's a lot to cover. What I'd like you to do is maybe go over those examples a little slowly and let it sink in. It's not that hard to understand, but it's not something that generally just jumps out at you. Like I said, once you start talking about different permutations for things, it gets a little fuzzy on exactly if it's going to be a permutation where the orders, orders are important in a permutation, but you have the permutation where you don't replace the choice, like in the locks. Like if you pick a 3 for the first number, it could still be a 3 for the second, it could still be a 3 for the third. But in the billiard balls, if you take out a 1 for the first choice, 1 can't be your second choice of your third choice because it's your first one. So let that soak in a little bit and go through those exercises or go through these examples that I gave you just maybe a couple times to let that sink in. That's all I had for you today with permutations. Thank you for making it this far. If you have any questions, reach out to me, and I bid you all a very well rest of the day. Thank you.